friends, in today's video we will solve questions 6 to 10 from exercise 3.1 of Matrices Chapter. In the previous two videos we have solved the first 5 questions. You can check those videos out. I have put them in the description below. Now let's solve question number 6 to 10. Let's start. So the first part of the sixth question gives us two matrices. And we have to find the values of x, y and z. Now we are given that these two matrices are equal. Okay. So always let us list out what data is given to us. Many times we are given certain data explicitly in the question, but often we have to find out the implicit data, the hidden data in the question. So since these two matrices are equal, what does that mean? Let us recall our matrices equality. The two criteria have to be satisfied. The first criteria is that the order should be the same. So which is the case over here. They are both of the order 2 by 2. So that criteria is satisfied already. Since they are equal, the corresponding elements are also equal, which means the first row first column element of this matrix will be the same as the first row first column element of the second matrix. So we just have to use this particular condition and we'll get the values of x, y and z. No difficulty at all. We just have to be clear with the concepts. So let's start with the first variable. There are 3 variables here, as you can see, and they are not in one single matrix. You have x in this matrix and you have y and z in the other matrix. So let's start with x. So this is the second row first column element. So since these two matrices are equal, this x value should be equal to the corresponding element, that is second row first column element, which is 1 in this case. So x is equal to 1. So we can always write the reason here, since corresponding elements of equal matrices are also equal. So using this criteria we are going to solve the problem. So x is equal to 1. Then I have y here. Y is the first row first column element of this matrix. That will be equal to the first row first column of this matrix, which is 4. So y is equal to 4. The same reason, because corresponding elements of equal matrices are also equal. Then the last variable we have to find is z. So the first row second column element is z. The first row second column element in this matrix is 3. That means z has to be equal to 3 for these two matrices to be equal. So how do we write that? Very simple. Z is equal to 5. The same reason is attributed to this also. So it is so easy, friends, to find out the values if you know the concepts clearly. Now let's go on to the second part. In the second part, again I have two matrices. Let's write that down. X plus y, 2 seems like a square matrix of order 2, and it's equal to another square matrix of order 2. Okay, so these two matrices are equal. So what does that mean? I use the second criteria, that is the corresponding elements of equal matrices are also equal. So what are my variables? X, y and z. Now here this is not so straightforward like the first part. I have a linear equation here. Let's write that. So this element is going to be equal to this element. So x plus y is equal to 6. The reason we can just write, since corresponding, I'm just using the short form, corresponding elements of equal matrices are equal. Okay. Always write the reason when you are giving the answers, because it tells the person who is checking that you know the logic. x plus y is equal to 6. Now that's the first equation. Then where do I have the variable? Yes, I have a z over here. So the second row first column element, that's going to be the second row first column element over here. These two are going to be equal. So 5 plus z is equal to 5. That's another equation I have. Then this one, x multiplied by y, that will be equal to 8. Again corresponding element. So x multiplied by y is equal to 8. So here I have the three equations. So this is the progress. Now what do we do is that, so if you see you have a product xy equal to 8. So maybe I can find the value of x in terms of y. So I will get x is 8 upon y, and I can substitute this equation in maybe the first one. Then I will get, so x plus y equal to 6 will become 8 by y plus y equal to 6. So all your quadratic equations, linear equations, all your skills are being put to test here. 8 plus y square upon y is equal to 6. So, are we getting quadratic equations? Yes, we are. Y square plus 8 is equal to 6y. So y square minus 6y plus 8 is equal to 0. Wow, that's the quadratic equation. Hope you remember all your quadratic equations concepts. So how do we solve this equation? So so I have to find the factors of 8 so that I will get the sum as 6, your typical quadratic. So I'll get 4y minus 2y plus 8 is equal to 0. So I will take out the y common here, and I'll take out the 2 common here. So I get y minus 2 into y minus 4 is equal to 0, which means I have 2 values of y. Oh, 1 is not enough, I'm getting 2 values. So y is 2 and y is 4. So wow, we started searching for one value and we got 2 values. Now let's find out the value of x. So I'll substitute the value of y in this equation. So I'll get x as either 8 by 2 or x as either 8 by 4, because there were 2 y values, which means my x will be either 4 or 2. So just don't confuse that when x is 4 then y can be 4. No, that's not the case. When x is 4, y will be 2, and when x is 2, y will be 4. Just be clear with that. Now these 2 values we need to substitute and get the value of z. So we know that 5 plus z is equal to 5. So now we have this equation 5 plus z is equal to 5. So just solve that. It's so easy. So this is the equation, so which implies that z has to be 0. So this value of z is not dependent on the values of x and y. Please note that. This is an independent variable, it seems, but x and y, they are very much dependent on each other. So let's write the final answer. So when I have x as 4, I will have y as 2. Just note here, when I put y as 2, I got 8 by 2 and I got 4. That means value of x as 4 we get when y is 2. Okay, and z anyway has to be 0 no matter what value of x and y is there. And when x value is 2 here, that time we had put 4 as y. So y will be 4 and again z will be 0. So this is the solution for this problem. There are going to be 2 set of answers, x equal to 4, y is equal to 2, z is 0. And the second set of answer is x is equal to 2, y is equal to 4 and z is equal to 0. Now the third part of the 6th question, again it has 2 matrices. Let's write that down. They are equal. X plus y plus z, x plus z and y plus z. This matrix is equal to 9, 5 and 7. First, let's find out the order. So there are 3 rows and 1 column. So the order of this matrix is 3 by 1. Since they are equal anyway, this order will also be 3 by 1. Now the orders are going to be the same. We are given that the two matrices are equal. So what does that mean? That means the corresponding elements are also equal, and we have to find the value of x, y and z. That is what we have to find. So once again we have to equate the corresponding elements. So we will get x plus y plus z equal to 9, x plus z is equal to 5 and y plus z equal to 7. These are the 3 equations. I think these are all linear equations. Yes, that's right. Now, one thing I can do is I can substitute the value, I can just substitute this third equation in the first equation. Y plus z equal to 7, I can directly substitute over here. Let's do that right away. So I'll get x plus y plus z, I can use the value of 7. So y plus z becomes 7 and that is equal to 9, which implies that x is equal to 2. Wow, I got my first value. Now, can I use this right away in some equation? Yes, I can. In the second equation, x plus z is equal to 5. So let's put that value right away. So I'll get 2 plus z is equal to 5. X is 2. So that means my z value will become 3. Wow, we got the second value also. Now only y is remaining. Where do I put? I'm spoiled for choice. I can put in any equation. So let me take the simplest one, the last one. Y plus z is equal to 7. So I know the value of z. So I'll write y plus 3 equal to 7, which implies that y is equal to 4. So here we are with all the 3 values. The 7th question says that we have to find the values of A, B, C and D, and they have given us again 2 equality of matrices. Let's write the matrix. A minus B, 2A plus C, 2A minus B, 3C plus D. This is equal to minus 1, 5, 0 and 13. What do we have to find? A, B, C and D. They are just confined to one matrix. That's a good thing. Now let's see what is the order. The order is 2 by 2. So once again, since the two matrices are equal, the corresponding elements should also be equal. So let's straight away write the equalities. So A minus B is equal to minus 1. The corresponding elements are equal. 2A plus C is equal to 5. 2A minus B is equal to 0 and 3C plus D is equal to 13. Now I can see that these two equations, the first and the third, have the same unknowns, that is A and B. So maybe I can just subtract one equation from the other. So I'll eliminate one of the variables. So let me just take, if I number the equations, it will be easier. So I'll just write equation 1 minus 3. So in that case, I will get A minus B minus 2A plus B equal to minus 1 minus 0. So I'm just subtracting 1 minus 3. So the B and minus B will get cancelled. So I'll be left with minus A equal to minus 1, which implies that A is 1. Great, I got my first value. Now straight away let me put it in the first equation and I'll get the value of B. So here I am. 1 minus B is equal to minus 1. So that implies that minus B is minus 2. Once again, B is 2. Now how do we find the value of D? There is only one equation which has D, and that is the fourth equation. So let's substitute the value of C there. 3 into 3 plus D is equal to 13. So 9 plus D is equal to 13. So D value is going to be 4. So the answer is A is equal to 1, B is equal to 2, C is equal to 3 and D is equal to 4. So this is the solution. The 8th question says that matrix A is a square matrix of order m by n. Then which of the 4 options are true? Option A, m less than n. Option B, m greater than n. Option C is m equal to n. And option D is none of these. Now let's see how to do this question. Now, matrix A is a square matrix. So what is a square matrix? A square matrix is a matrix where the number of rows is equal to the number of columns. That is, in this case, since m by n is the order of the matrix, m should be equal to n because it's a square matrix. So which of the options should we choose? Definitely we have to choose option C. That is, m is equal to n. So option C is the correct answer. For the 9th question, let me first write the two matrices. So it's 3x plus 7. Now we have to find out for what values of x, y and z these two matrices will become equal. Obviously there will be so many possible values of x and y, but they won't make the two matrices equal. We have to find that combination of x, y which will make the two matrices equal. So how do we solve this? First, let us assume that the two matrices are equal. That's the only way to find out the answer. So let's first equate it. So suppose this matrix is equal to this matrix, then what will be the implication? The implication will be that the corresponding elements will become equal. So what are the so once again I'll repeat, for such a type of equation, for such a type of question. So for such a type of question, we'll assume that the two matrices are equal and then find out the values of x and y. So since the two matrices are equal, the corresponding elements have to be equal. So let's equate the corresponding elements. So 3x plus 7 will be equal to 0. That is one equation we got. Then 5 is equal to y minus 2. That's another one. How about this? Y plus 1 is equal to 8. 2 minus 3x is equal to 4. So whenever you are faced with a question which confuses you, always take it step by step. Don't get overwhelmed by the question. Always try to see what can be done step by step. So this is what I do here. I have got the equations. Then I go to the next step, which is to solve these equations simultaneously perhaps. Yes. Well, I can directly find out the value of y from either of these two equations because there is only one unknown. So any equation you choose, either this or this. So if I take phi equal to y minus 2, I'll get y as 7. Interestingly, you will get the same value if you use this equation also. So one value I've already got. Now let me put this value of y in any of the other remaining equations. Oh, I don't even need to do that because there is one equation where I have only x. That's wonderful. So I can directly solve this. So I will get 3x is equal to, I'll bring this over here. So I'll get minus 2. So x is minus 2 upon 3. This is another value. So here are the two values of x and y. Now these two values when put in this matrix will make the matrices equal. So which option will that be? That will be option C. So the answer is option C. That is y is equal to 7 and x equal to minus 2 by 3. Hope you understood how to solve these type of problems. So the last question is really not a matrix question. It's basically testing your probability skills. So we are asked to find out all possible matrices of the order 3 by 3 with each entry 0 or 1. So I have a 3 by 3 matrix, a square matrix. These are my matrix elements. this is a general form of a matrix. I don't know what the exact elements are, but I do know the data that is given is that this is 3 by 3 and the matrix elements are going to be either 0 or 1 for all I and j. So I've just written this mathematically. Aij is either 0 or 1 for all ij belonging to maybe the number of rows and number of columns. So now how do we proceed with this? This is a permutation problem. So let's start. Now see, this A11 can be either 0 or 1. So how many possibilities are there? There are going to be 2 possibilities, right? So I'll just write here 2. And now remember, in probability, whenever we write a solution, there are 2 things. One is and the other is or. So and comes when you're writing one possibility. So we are going to write the first possibility, and in the first possibility, the first element can have 2 options, either 0 or 1. And the second, so whenever we say and, we have to write the multiplication sign, and the first row second element can also be either 0 or 1. So it's not that if this is 1 then this should be 0, or if this is 0 this should be 1. No such condition has been put forth. So this can also be either 0 or 1. And the first row third column can also be either 0 or 1. So again there are 2 options, right? So this finishes the first row. Now let's come to the second row. So again there is an and the second row first column element can also be 0 or 1. So once again there are 2 options, and A22 can also be 0 or 1, and A23 can also be 0 and 1. So there are again the same 2 options. Now coming back to the third row, A31 can also have 2 options. A32, I'm sorry, this is A32. A32 can also have 2 options, that is 0 or 1, and A33 can also have 2 options. That's all. Now this is my one possibility, and this is the only possibility in this case. Now I can't have any other possibility, can I? I can't have. So this is my only possibility. So I just need to find the answer by multiplying all the 2's. There are 9 2's. So that is 2 raised to 9, and it just comes up. Now after this again you have again plain mathematical calculations. So if you don't know, like me, directly, if you don't know the value of 2 to the power of 9, I'm very bad at it. So I always do it, I always work it out. So it is 2 raised to 4 into 2 raised to 4. I'm really primitive in this. So it is 16 into 16. So that comes to 512. That much I know. So this is the answer. So there are 512 matrices of the order 3 by 3 which you can construct with entries either 0 or 1. So that's a huge number actually. So the correct option is option D, which has 512. So these many matrices are possible of the order 3 by 3 with entries as 0 or 1. Now I just want to explain a little bit more. What if they change the question to 2 by 2? In that case, so instead of saying that find all possible matrices of order 3 by 3, if they say find all matrices of the order 2 by 2, then how would your answer change? Let's just see that for curiosity. So here I have a 2 by 2 square matrix. So these are the matrix elements. So let's write down the general form. So Aij can be either 0 or 1 for all ij. So that means my first matrix element A11, it has 2 possibilities. Either it can be 0 or 1. So there are 2 possibilities, and A12 can also have 2 possibilities, either 0 or 1. And A21 also there are two possibilities, and A22 also has two possibilities. So same approach, only thing the order has changed. So I will get the, so I've just written here, I've just given the bracket notation, this is really not required. So the total number of matrices will be nothing but 2 raised to 4, which is 16. So there are 16 matrices of the order 2 by 2 with entries either 0 or 1. So just see the huge jump. A 3 by 3 matrix has 512 matrices and a 2 by 2 order has 16 matrices. So this question can be, it can be reframed as any, in any form. Instead of 2 by 2, they can give 4 by 4, they can give 3 by 3. So once you know the method, you can solve any type of problem. So friends, we have completed solving all the 10 questions from exercise 3.1. So do let me know if you have any doubts or any point you need clarification, because the whole aim of having this channel is to minimize memorizing answers in maths. Instead, let us understand and eventually enjoy maths. So till we meet in the next video.